real short leash this morning, and then Deb threatened me with a hook. So I'm kind of in a crossfire here. Welcome. I'm glad everyone could come and participate with us this morning as we are at this initial stage, really, of our forest plan revision process, looking at our new 2012 forest planning rule and looking at a different way that we are approaching the processes we use to develop plans for our national forest, as well as maybe some of the objectives for how and why we manage our national forest. The assessment phase, which is what we're in right now, it's going to last us about a year. We're looking at a bioregional assessment so we can get a landscape scale picture of the Sierra Nevadas, and then each forest is going to be developing their individual assessment for their forest plans, which then helps us set the stage for developing of individual forest plans for the first three will be the Sierra, the Inyo, and the Sequoia National Forest. And then as we progress and resources permit, we're going to essentially march north of the Sierra Nevadas. Then we're going to be revising the forest in Northern California, and then we'll be moving back down to the south. So this is setting the stage, and we're learning through this exercise as we go. About 20 years ago, I remember there was a lot of interest about it takes a community to raise a child. And I think the same could be said. It takes a community to help us manage our public lands. And so this is part of that community and helping develop that scientific underpinning and understanding and shared understanding of the needs, the capacities, the issues, the challenges that we have. And I hope we all take this meeting today and as we move forward in that kind of a spirit, because the water, the landscapes, everything that happens on these national forests is really important, not just to us today, but to the community of the future that really aren't here and present and they need someone to speak for them. I really know that as we move forward in this, we're going to have a lot of challenges figuring this out. We aren't going to get it all right the first time. And I don't think that should be our goal. Our goal should be to share the learning, and as we move north, get it better each time, because each time is going to be a new learning exercise. So with that, I'm going to pass it back to Joanne. I want to say thanks to everyone and being part of this community of learning and caring about what these landscapes are about and how to help them be as healthy, with as much vitality, and offer as much for all of us as they can. So thanks. Oh, sorry.
Thank you, Joe. So I just want to frame up the conversation for the day. This is a workshop to focus on the aquatic fire piece of our assessment that's, as Joe said, currently underway. There are a number of handouts on the side. I'm not sure everybody had a chance to pick one up. And there's one in particular that has some different colored boxes. So I see yours, so I'm going to pick yours up. So if you have a chance, I'd like for you to pick one of these up and sort of consider it as we go through our day. It represents our early thinking on how to integrate the social, economic, and ecological pieces of our forest planning effort. Our regional planning team has put some thought into this, and we're trying to figure out how to tell this story in that very integrated way. So we'd like you to be looking at that through the course of our conversation today, and if ideas come up, if you see something that's missing, if you see other arrows that ought to be going in different directions, it'll become obvious once you take a look at it. We're really interested in your thinking around that diagram. Joanna's put together two fabulous panels for you. And we're recording everything that's happening today. So I think the format is everyone gets 5 to 10 minutes, or we'll sort of play that by ear. We want everyone to get enough time to share your thinking. Then we're going to do some question and answer. Then we're going to have folks get into small groups, and we've got a small group exercise to get us thinking and talking some more about this. We're going to break for lunch. Joanne's given us about an hour and a half. Erin was kind to point to where there's lots of choices in the area for lunch. We're going to come back and have a second panel. We'll go through another round of Q&A, and then we'll just see how the time is going, and we'll see if there's time for another breakout group. But generally, that's the format for the day. So, does everyone have an agenda as well? I think there were agendas out on every table. The last thing I want to do is quickly run through the purpose, the sorts of questions that we're wanting to think about today. So, what is the objective? Sustainable ecological integrity and ecosystem services. And we're really focusing on water of aquatic ecosystems today. What is working in relation to sustainable aquatic integrity and why? What's working and why not? And then what would work? So we're going to go in order, right down the line. And you can use this or not, all right? It's kind of up to you. If you can't hear, will you just kind of put your hand up in the air?
We need to use the mic so Nikos can record it. But there's a mic at the podium. There's a mic at the podium. Just speak kind of close to it.
All right, and everyone has a PowerPoint as well, right? Okay.
You can turn that one off there. Thank you.
Can everybody hear me okay now?
Turn the light.
Okay. Well, good morning. I'm going to be running through this PowerPoint pretty fast. I don't have a lot of time here, and since I'm first, I'd like to try to stay on time. And before I forget, I wanted to thank Erin and Don to point out that there are some publications back here on the table that were provided by our colleagues at the Department of Water Resources. They weren't able to be here today, but there are some of the reports from the state water plan from mountain counties in the North and South Lahontan region. So if you're interested, please pick one up and take it home with you. Take a look. So my role, as I understand it today, is to talk about what is. Whoops. Okay.
That's the, hit that button again to relight the screen, and then the right arrow.
That was the right arrow.
You got help.
Okay, hold on. I'll do it this way. There. Okay, sorry. All right, so I'm going to talk about very briefly what is in parts of the topic papers which are on the wiki site for the assessment. So I'm going to talk about parts that are related to water, and those are in, if you want to find them, they're in chapters 2 and 8. So if you've ever seen a talk I've given, you've probably seen a slide similar to this before, and I think it's important just to realize that in the Sierra Nevada, just like the rest of California, the national forests are located in the headwaters of the major rivers, and they're very important in terms of the quantity of water that they provide. And then the beneficial uses, I think what I'd like to draw your attention to is that we have a storage capacity, infrastructure, constructed storage capacity that's relatively large relative to the amount of runoff that we would tend to get on average, so we're able to capture an awful lot of the runoff that's coming down the rivers. Another comparison I think is useful is to look at the amount of evapotranspiration. That's the ET figure you see there. And so a lot of speculation and research is going into how much more water maybe you could accrue basically by cutting down trees. And if you were to cut down all the trees, that would be quite a lot of water. So just for reference, that's about how much it would be. And then as you can also see, there's this water is pretty important to the state. 30 million domestic consumers, roughly. This is by adding up all the different projects, beneficiaries, and 4 million irrigated acres, 92% of the hydropower. and also, of course, very important for recreationists. And just, again, really quickly, I wanted to point out, I didn't really cover this in much depth in our assessment, but the Sierra Nevada Ecosystem Project report back in 1996 highlighted that there was 3 major disruptions, if you want to call it that, to the aquatic systems in the Sierra Nevada that are still with us and have a very great influence, and that includes not only the water supply infrastructure, but the effects of hydraulic mining and the attendant mercury accumulation. So I am going to kind of go very quickly through these slides because I don't think I'm going to have a lot of time. I think the main thing I want to point out here is that if you look at our own assessment of our watershed condition, which we did in 2010, we would give ourselves somewhere around, a D plus or a C minus maybe in terms of how many are functioning properly. On the other hand, there aren't very many that were in the very bottom bracket, so kind of a mixed bag of results. If you look at what the state has done in terms of listing watersheds or water bodies for impairments that are directly related to silviculture and livestock grazing, which are 2 of the main activities on national forests, you can see that it's a relatively small number, but that's a little bit misleading because some of those water bodies are quite large. One thing to notice, though, is that the numbers have overall, they've either stayed steady or they've gone down. They're not heading up as of 2010. I'm not going to talk too much about our best management practices evaluation. I think hopefully this will be available, this PowerPoint. I can make it available if you'd like to see the results. And this will be included in a report that the regional office will be putting out. Just a couple of things. This is the implementation results. So this shows to what extent the National Forests implemented the best management practices that they said they were going to do in the NEPA documents. And you can see there's some disparity. Overall, it's been improving for all the activities, and it seems to be highest for the practices that are related to vegetation management, timber, and fire. If you look at effectiveness, the scores are lower. We're looking at the effectiveness of just the implemented ones here. And the numbers are lower. They're trending upward in some of the activities, but they're not trending upward in others. I do want to point out that we revised the best management practices for some of these, the engineering, range, and one of the mining best management practices were changed in 2011, and these results don't reflect those new BMPs. We'll have another monitoring report coming out in a year or so that will include those. This is something I wanted to spend a minute or so on. The question comes up a lot as well, what's really the biggest impact to water quality on forested lands in the Sierra Nevada? And it really depends how you look at it or what the timing is. So these are some numbers. These are pretty much just estimates. I wouldn't say they're highly accurate. They're the best that I could come up with, though. And so if you look at it, you would see that based on records of reservoir sedimentation, that gives us sort of the overall sediment yields from forested watersheds in the Sierra Nevada. It has a range that you can see up there over a couple orders of magnitude. And those are pretty much within what you'd expect for managed forested watersheds nationwide based on the literature. If you look at wildfire, that's a much larger number, but it only persists for a short period of time. Then if you look at vegetation management, that's a much lower number, but then again, that's something that would probably be persisting for longer. And so it's hard to compare it directly. The roads is a pretty significant number, so that is it overlaps the range for the reservoir sedimentation. So in other words, in some situations, the roads could be 100% of the sediment yield based on these figures. And then livestock grazing, in terms of sediment, is a lower number, but there are other water quality concerns related to livestock that aren't related to sediment necessarily. So I think this has come up in a number of situations where it's the question is, well, is it better to go in, do some aggressive fuel treatments, which do involve roads, do involve removing trees, or is it better to let the fires burn? And the answer really depends on how often you have fires. Bill Elliott, a researcher with the Rocky Mountain Research Station for the Forest Service, did an analysis like that in 2010, and he ended up concluding that it would overall be better to go ahead and do the treatments, but not by as large of a margin as you would see here. So climate change obviously is affecting the Sierra Nevada already. We're seeing increasing temperatures. There's maybe not a big change in precipitation, but there's more of it coming as rain and less as snow, and this has a lot of implications in terms of flooding. The amount of water that will be lost to our systems by evapotranspiration, less groundwater, probably lower flows in the summertime. I think Michael and Joseph will talk about that and the effects on the aquatics later on. And then probably some increasing fire impacts as fire severity and size increase. And this is just one illustration from down in the southern Sierra. This is on the Kern River watershed. So this is one way to look at what kind of trends have happened over the last 50 to 80 years. So this is plotting cumulative precipitation on the x-axis against cumulative stream flow. So if there was no change in the relationship between the stream flow and the rainfall, you'd expect this to plot as a totally straight line. And this is, kind of looks like a straight line, but you can see it's got some squiggles in it. So something's going on there. I don't know what. It doesn't have any major secular bends that just persist. But I have looked at a similar graph for the Merced River where it comes through Yosemite National Park. And by comparison, that one plots as much more of a straight line. So there may be some signal from management in here, but I don't know what that is. So just in summary, I think it's pretty clear that the national forests in the Sierra Nevada are pretty important for California's water resources. And that importance may increase due to the effects of changing climate. It's possible that some improvements in water yield might be achievable through forest management. That's not really clear yet, though. Chronic sedimentation can be reduced through improved management of roads and grazing, and overall the adverse effects of wildfires outweigh the effects of fuels treatments. And that, I believe, is all I have.
Thank you, Barry. Do you want us to bring up the lights?
Sure, you might as well. Hi, I'm Greg Haller with Pacific Rivers Council, and I have to apologize, I do not have a PowerPoint today. The thief that broke into my car has my PowerPoint along with my computer. So I'm just going to introduce myself and PRC a little bit to you and highlight a report that we've recently published. Pacific Rivers Council has a long history in forest planning in the Northwest as well as in Northern California. We began in the Northwest Forest Plan and were instrumental in the development of the aquatic conservation strategy within that plan. Our work in California started in 1998, with the publication of the Aquatic Conservation Report. We did a publication on thinning and water yield, focus on frogs. We've been involved with some litigation, as some of you are probably aware, headed to the Supreme Court on behalf of the Obama administration. We held a workshop on the Sierra Nevada Ecosystem Project, have a report regarding that. And we've been working with Sierra Forest Legacy and have developed our latest publication, which is Conservation of Freshwater Ecosystems on Sierra Nevada Forests, which I would have had a slide to show you and talk about some of the recommendations in there. However, I do not. Just a couple of points that I'd like to make since the topic is on fire. I think one of our recommendations is that prescribed fire in riparian areas is going to be an important part of management. We think that mechanical and some commercial thinning, it may be appropriate in areas, but that can never really replace the role of fire and the ecological processes that fire brings with it. All of you know that the waterways and the riparian areas, the meadows in the Sierra Nevada are where all the diversity is, and PRC is going to advocate for those areas. One issue that is going to be important going forward, and I think the previous speaker mentioned it, was the role that roads play in sedimentation and in future management on the Sierra Nevada, especially with the emphasis on thinning and other treatments. The problem with that is that it comes with an extensive road network, and PRC has long advocated for reducing road densities across the landscape, and that's something that we'll be doing so in the planning process going forward. I think a couple other points I'd like to just bring up. We do like the idea of the establishment of reserves, whether they be riparian reserves or meadow reserves. And that doesn't necessarily mean that no management would occur in those areas, but they would be light touch types of activities to kind of serve as anchor points for the diversity that exists in the landscape. I think that's, I'll just leave it right there. My slides were a little more detailed, but can't really. Thank you.
Thanks,
Bring the lights back down.
Oh, the report is on our website, pacificrivers.org. It's also on Sierra Forest Legacy's website as well.
We got a copy here, somebody would like to look at it.
Oh, great.
Good morning. My name is Michael Kellett, Fisheries Program Manager in the region. I picked my title slide deliberately. This is a hot cutthroat trout that I caught at Pyramid Lake December of last year. And hot cutthroat trout is a convenient poster child, if you will, for this discussion. Because it exhibits, has the capacity to exhibit a very diverse life history. This individual obviously is part of what once was an adfluvial population, and we have historic records in museums now of adults reaching 40 pounds. Now, these fish migrated annually from Pyramid Lake, which is a sink in the Truckee River system, up through Lake Tahoe, up into the upper Truckee and Little Truckee River systems to spawn and then return, living in excess of 8 years quite often. We'll talk a little bit more about the importance of this diversity later in this discussion. Many of you know Dr. Pierre Mol. He's featured there holding a Sacramento pike minnow, part of the aquatic biodiversity of the Sierra Nevada range. As we begin to consider how we would define aquatic biodiversity for this forest plan revision effort in Sierra Nevada, we wanted to be more inclusive than perhaps has been done in the past. We looked at all 49 fish species that are native to the Sierra Nevada range. 17 of those happen to have special status, as in threatened, endangered under federal ESA, Endangered Species Act law, or Forest Service sensitive. That's a fairly high percentage. We also included 10 amphibians and 1 reptile, pond turtle, and 18 invertebrate species that are obligate aquatics. This map, which has been available for some time, features the richness and distribution of these species across California, and you'll notice that there's a lot of concentration of that diversity in the Sacramento River Valley and the Pitt River. But there's also, as expressed in the inset, a high level of endemism, which is local, very localized diversity. And featured in the pictures, I included things like a Margotifera, the western pearl mussel, Lahontan redside, it's Pacific lamprey, and an Owens tui chub. Life history is very important. Life history diversity is very important to persistence of species in a dynamic and dynamic ecosystem that is maintained through various disturbance regimes. A very perhaps eclectic display of that life history diversity might be something like Oncorhynchus micus, which we know as steelhead or rainbow trout. And they can manifest all four of these life histories, anadromous and fluvial, and resident, even in the same populations. And some of the fish, like the Lahontan cutthroat trout we talked about earlier, might only exhibit 3 of these. They were not anadromous, but they did have fluvial, and resident life histories. And then the effects of management quite often has resulted in obstructions, be those physical or chemical, obstructions to completing those life histories. And we're now dealing with some of the consequences of those earlier land management decisions and those barriers that persist today. If we think about a typical sort of dendritic stream network and what is a collection of habitats and habitat uses for whatever the species assemblage might be here, we have spawning and rearing areas, we have migratory corridors, we have places for the organism to seek shelter in high flows and cool water in low flows, typical of late summer, for example. If we were to superimpose, let's say, a transportation network on that habitat patch, what we see is now we have a highly segregated set of habitat patches, some of which may not continue to function for the species assemblage, depending on their needs, and more importantly, on the disturbance regime, because of course superimposed on this network of habitat patches is that fire disturbance regime, for example. What is going to happen with these smaller patches, which are much smaller than the patch size of the disturbance regime? We're talking about fire. And will they persist through time? And can they be recolonized post-disturbance in the event of local extirpations? In addition, we need to consider the disruption of gene flow. That heterogeneity of populations is very important to their persistence. This has been borne out time and again, perhaps most recently by some research on sockeye runs up in Alaska. It was an economist's perspective on why certain salmon runs are consistently valued in the commercial fishery there. So big social implications to that. And what they found is that those that have to be closed least frequently, like in Bristol Bay, for example, where it's closed like 2 out of every 40 years, are consistently valuable commodities, produce consistently valuable commodities because of their diversity. The reason Bristol Bay fishery closes so seldom is that they have a very diverse assemblage and life history expressions there, and excellent connectivity, providing for the perpetuity of those species. This next segment here was produced by NOAA Fisheries. Everyone's familiar with the Central Valley. This is a depiction of the contributing watersheds, the Sacramento River, and in succession, as that habitat connectivity was lost through water developments, the names of the dams are listed. And that progression of development or building continued through 1989, the construction of Black Butte. What we have left is 20% of the historic anadromous fish habitat that actually has anadromous fish in it. It is commonly referred to as the fishbowl. Most of that habitat that is now in the Central Valley was not spawning and rearing habitat. It was a migratory corridor. The remaining populations are compelled to spawn there because they have no access to their historic spawning and rearing grounds. I've also added a backdrop of Forest Service administered lands, and you can see that the majority of those spawning and rearing habitats were managed by the National Forest. So that was a sort of Sacramento Basin scale, very large scale view of connectivity. Let's take it down to a forest level. The graphic on the left is what I developed for part of the regional bioassessment. It's a network of habitat patches, each with its own color, and that shows the fragmentation of other dams, above the rim dams in most cases. And you can see that that is a highly fragmented habitat network. The black dots are the dams or diversions that do not have fish ladders or other connectivity engineering controls there. And then there's some stars that are natural barriers, high gradient barriers such as waterfalls. And then if we got down further, I would focus your attention here if I can get an arrow. Now I'll use the, where's the remote control?
Just skip the slide too.
Oh, that's bad.
I don't know, somebody moved.
I'm not able to get my cursor. Oh, it's hiding, thank you. That part of the world right there is Chiquito Creek. Chiquito Creek's provided on the inset to the right. So what appears at the sort of forest-wide or gross scale to be a small connected habitat patch is actually highly fragmented by a transportation network superimposed on that habitat patch. The data that we have from forest-wide aquatic organism passage inventory work on our transportation system indicates that about 84% of these on average are barriers to aquatic organism passage. So all of the red dots on Chiquito Creek stream network over there on the right-hand map, 84% of those are barriers in all likelihood to aquatic passage. So there are actually many colors that should be represented in that habitat network. I'll leave that to the forests to further develop that, refine that. But included in the inset, there's a picture of a hardhead. It has sort of an adfluvial, used to be more fluvial, sort of life history expression where they grow up and attain a fairly large body size for cyprinidin, the larger stream networks, and then work upstream into those natal spawning grounds annually to reproduce. And what happens to that life history when they are sort of constrained to these highly fragmented habitat networks? That's one of the reasons they're now a Forest Service sensitive species. But the physical barriers aren't the only habitat fragmentation we're dealing with here. I have here a map of the Tuolumne, part of the Tuolumne system. There are three large reservoirs shown. That is Cherry, Eleanor, and Hetch Hetchy. They're all regulated flows down in Tuolumne. Now, on the inset graphic, you will see on the right y-axis cubic feet per second displayed, and that's the trace in red on the graph. And you can see that daily those flows are regulated somewhere between about 30 CFS and 1100 CFS, and very abruptly every day. That's because there is some recreational rafting apparently goes on in the lower Tuolumne River, and somewhere in the agreements way back, folks agreed that we need to provide rafting flows down there, which is probably fine and dandy if you're a rafter on the lower Tuolumne. But what if you're a foothill yellow-legged frog trying to complete your larval cycle on the lower Tuolumne? And they do exist, or at least did historically. Those abruptly ramped flows will either strand larval frogs on the receding limb of that, or mobilize them on the ascending limb of that diurnal hydrograph there. And what is the effect of that ramping of flows on the water temperature? That's the trace in blue. It looks more like an EKG read. As those of you familiar with looking at water temperature data recognize that this should look much more like a sine wave. Should be warming from late morning through afternoon, and then cooling through evening on into early morning. What this does is actually the inverse. It actually cools quite abruptly at about 11 o'clock in the morning, and then starts to warm at about 5 or 6 in the evening. And if you were a mayfly or a caddisfly trying to emerge on that day, what would that do to your rhythm? I think it would interrupt it greatly. And I've also included, the riffle sculpin, California roach there, some less mobile fish species to consider the implications to those species in a highly managed flow regime like that. My last slide here is a depiction of what we've come up with so far to represent aquatic ecosystem integrity. This is a combination of the biological diversity in the aquatic habitat that we've discussed so far, and some of the factors that modify or affect or influence that diversity, such as aquatic habitat connectivity, temperature regimes, certainly, invasive species in the aquatic habitat. I've depicted for you here a little slice of heaven up on the Kern Plateau, and 3 of the native trout species native to that region. Little Kern golden trout, Kern River rainbow trout, and California golden trout. And I thought it would be interesting to take a look at what was considered a critical aquatic refuge in the 2004 framework. Those polygons are outlined in black on that map. And you can see that they do not necessarily represent the highest ecological integrity watersheds in this case. Some of them appear to be much smaller than watersheds. So I think it would be useful at some point to have a discussion on what should our aquatic refuges look like? Are they functional aquatic refuges if their patch size is greatly overwhelmed by what we consider an expected patch size in our disturbance regime? I think I'll leave it at that. Thank you for your time.
Thank you.
So this is, I guess, kind of a messy looking graph, but Joanne wanted me to talk about some of the things we look at as far as differences in fire seasons and the relationship to how fires will burn in different seasons or under different conditions. And one of the things that we look at is this energy release component, which is part of the National Fire Danger Rating System, which all of you have probably seen the smoky signs that say, high, moderate, extreme kind of thing, low. And that's all based on this information that's collected from these weather stations all around the state that are remote access weather stations, that all the data goes into the system and produces this kind of information. So we have information like this is the Quincy weather station, and we have information from 82 to the present, basically. And so the energy release component is the potential energy with from a fire in BTUs, basically, if it burns. So we track that heavily on how dry the fuels are, because that's what basically releases the energy. If the fuels are really dry, you get a lot more energy than if they're wet. So we look at this as fuel dryness, basically. So I picked a few years here just for you guys to get a feel for it. This was last year, it's somewhere above normal and not all the way peaked to the highs for that station. And then, you have the lows, and then we have 2011 and then 87. So where they kind of bounce around there. So what I'm trying to show is that not every fire season is exactly the same. And so you have your bad seasons and your good seasons, and so, or your dry seasons and your not so dry seasons. And those can become, one might be something that fires in there might not be desirable at one level, but maybe they're desirable at the other level. So, and then in my subsequent slides, I'm going to just run some fire behavior modeling consistent at this, at the midpoint of this below 50 percentile, and then between 90 and 97th percentile. And so it's kind of that really dry season versus, more of a normal season or below normal. But so those percentiles are that 50% of the time, 50% of the time, below that's in that data record falls in that area. So what I did was I just used these 4 fuel models to run my fire behavior. And so I used just a heavy brush, and that's kind of like what it looks like, and then a lower grass, and then just a shrub kind of understory, and then a really just timber litter, low litter, kind of typical. And so I went and grafted these out, and this is flame length, and it's kind of hard to see here, but I divided up my data from 97 to 2011, so like the last 15 years, and divided that in those categories of the 90th to 97th percentile, and then also in the 0 to 50. And I also did that for that earlier time step from 82 to 96. So divided the 15 years or 30 years into 15-year increments. So what I get out of this is flame length. So these are the high, and this is like the more recent 15 years, and then this is the the older 15 years. And so what I'm seeing, and I know this is just one weather station out of multiple weather stations, but one thing is that you're getting differences in fire behavior for those same percentiles, so that we're drying out. As you go this way, you're drying out. So the older stuff is moister for the same percentile, and then this is getting drier. And same on the lows. But what I'm trying to illustrate is that you have opportunities here for those 50% of the time, you're still in an area where you're going to get less fire behavior. And incrementally, it looks like it's changing as we get into the future. And so brush is more affected. You get higher flame lengths on brush, grass, less flame lengths. And then over here, this is, really benign. It doesn't really change that much in that just litter layer that you have under a forest. And then corresponding with that is this is rate of spread. So you have fairly high rates of spread in the brush, and then really low rates of spread as you go down to the forest litter. So there's a big discrepancy basically between the high-end fire seasons and more of a normal fire season. And so not all fire seasons are created equal, not all days are created equal, and so you can get different effects. And I think the surprising thing, somewhat surprising, are that at least with this one sampling, that there was, a little bit of a blip between the earlier, a little more moist regime in those first 15 years than, the more recent 15 years. There's that little bit of change too.
Hi all, my name is Rene Henry. I'm the California Science Director for Trout Unlimited. For those of you who aren't familiar with TU, we are a conservation and angler organization. We've been around for over 50 years. We work to protect, reconnect, restore, and sustain cold water and anadromous fisheries and the systems that support them all over the United States. And this is my first engagement with this forum, so I guess most of what I'm going to focus on is some of the work that we've done to support the fish populations and the habitat that we are interested in. And we've done that work at a range of scales, from the grassroots individual project scale with volunteers from our local chapters to the landscape scales partnering with the agencies. So I'll talk about that kind of whole picture and the resources that we have that are available, and try to highlight key issues for us along the way. Just as a quick entry point to that, it's been great hearing other people's perspectives up to this point, and a number of things that have leapt out at me just in terms of framing what the big issues are. One is, for us, grazing, roads, invasive species, these are all as big issues as mining and dams, and they're issues that are affecting trout in our upper watersheds right now. So those are big items. And the other thing that hasn't really come up that we put a lot of emphasis on is just the evolving science of restoration. and stewardship. A lot of what we try to do is really proactive, solution-focused, looking ahead, trying to see where we need to go, and also figure out ways to quantify that so that we are feeding back into our restoration knowledge base and making the things that we do more effective as we move forward. So I have way too many slides. I'm going to skip over many of them, but they're just here to kind of give a really quick overview of what we're up to. So there's three big things I'm going to talk about. One is work we've done on mountain meadow restoration. Another is our Conservation Success Index, CSI, which some of you may be aware of. And then a third is some work that we've been doing in partnership with the Nature Conservancy and applying to BLM lands all over California, just similar to what we saw earlier, which is an assessment of just aquatic conditions for a range of aquatic species on the landscape scale, and then figuring out how to apply that at the project scale to prioritize projects more effectively. So with our Mountain Meadows work, there's an increasing interest in restoring mountain meadows because of for a variety of reasons. One is the long history of impact, primarily from grazing and also more recently from fire suppression and climate change. But another reason is just the interest in them as sponges in the upper elevations to buffer against climate change and just build our evolving larger distributed storage complex in the state. So we're not just dependent on all these bathtubs, but our landscapes are more like sponges that retain. As an entry point to our engagement with mountain meadow restorations, we picked areas where there was an overlap with California's native endemic trout species because they're important to us, and also because they really, as you can see, as you move around the state and the species, hit a really diverse range of habitats across sort of the mountain ecosystem. So if we needed a place to engage with mountain meadow restorations, they give us a good slice of what's going on out there. And there's been a lot of approaches to restoring meadows. Grazing management, vegetation manipulation, fire and fuels management, road maintenance, barrier removal, and then some more geomorphic, heavy-handed remeanders, plug-in ponds more recently. So, and a lot of these things in combination on different projects. And some of the goals of the restoration have been varied. In some cases, like this one, this Forest Service plug-in pond project that was done up in the McClellan Red Band Trout Refuge area on Trout Creek, you have a project that affects the habitat of native trout that potentially has a lot of benefit for trout, but that doesn't actually have trout or fisheries in general as a direct management goal for the project. So one of the things that we're really interested in is integrating target species, sensitive species into projects in an effective way, so you make sure that if you're going to take the time to do a restoration project for hydrologic functionality, it's also being effective for aquatic species, and it's doing the most that it can. So over the last 4 years, a coalition, including ourselves, California Trout, the University of Nevada, Reno, and UC Davis, has reviewed a whole suite of mountain meadow projects using a tool that we developed called the Meadow Restoration Fish Analysis Tool. It's really Mr. FAT for short. It's really simple. It's just a kind of a conceptual framework for assessing the limiting factors for a particular target species, and then looking at what a project or a proposed project is going to do for the habitat and how that does or doesn't address those limiting factors. And this figure is from our initial report, which is available. This was published a couple years ago on the first 14 projects that we looked at. We've done another 6. And this just gives you a sense of how basically on the x-axis is how the projects did relative to the total need or the body of limiting factors for fish, and then on the y-axis is how the projects did relative to their own scope. So like a grazing project, how good did it do at addressing things related to grazing? And if the dam is the big issue and grazing is only one portion of it, that's what's reflected on the x-axis. And you can see that, you know, different sorts of projects like the blue dots are pond and plug projects, so they don't all shake out the same, but they're all, you know, kind of in the upper quadrant of this plot. So they all have a fairly robust effect on the limiting factors associated with fish or native trout in this particular case. And then if you add grazing components to that, you can see that, you know, it's all over the map. Some of them do not even a great job at addressing the issues that they set out at. Some do a really good job because that's the primary limiting factor for the fish in that area. Some that are coupled with pond and plugs do a really good job. Others, not as much. So the idea here is that by looking across all the different projects, you can figure out what methodologies are useful in what cases and what things worked, what things didn't, and we can just be a little bit smarter about choosing the way that we approach restoration. And this is just a graph that explains how the Mr. Fat works. Part of the reason I made this presentation have too many slides is just so it can be there in the resource space and it can trigger people's memories about what's out there if you want to chase it down with us later. Another thing that we did as part of this effort was we developed a document that's just about doing monitoring in a way that makes sense. And the real focus of this was you want monitoring not just to be able to effectively capture change over time, but you want it to be able to quantify the effects of your management and stewardship actions at the scale that's appropriate for your target species. So if you are doing a project that affects things that relate to fish, like temperature, vegetation, shading, but your monitoring doesn't quantify or capture change or the effects at the habitat scale, then you haven't done your job and you're spending a lot of money on monitoring. It's not actually going to be able to give you the improvements that you need and enable you to be more fiscally responsible by making really good adaptive management decisions going forward. So we this past summer took the Forest Service Level 1, Level 2 habitat typing protocol. We made it a little bit more robust. We did it for all of the 5 reaches of the upper Truckee River above Tahoe where there's currently restoration going on. And then we coupled it with some really simple hydrologic modeling and with some ordination analysis on fish data also collected by the Forest Service to just come up with relationships between specific habitat scale attributes and what the fish are doing. And I should say that this work and a lot of our meadows work was funded by NIFWIF through their Mountain Meadows initiative. And this report is in draft form right now. It's being reviewed by the Forest Service and a bunch of our other stakeholders in the Tahoe Basin, and it'll be available publicly on May 1st. We also have had for quite a while this tool we call the CSI, the Conservation Success Index. And the CSI basically looks at the conservation success of native fish species geospatially, range-wide, and scores them across a number of different categories. And I know I'm hauling through this, but there's a lot of information about the CSI available, and then comes up with population integrity scores at a Huck 12 watershed scale that can then be applied more broadly at a larger landscape scale. And it's really comparable to the U.S. Forest Service watershed condition class and prioritization information in the Northwest Forest Plan. Some differences in terms of the ways that the data is quantified and the sources of the data, but just conceptually similar. So the CSI scores projects across, in four groups and 5 different indicators, and uses the combination of those different things to come up with an overall condition. This example is for Eagle Lake rainbow trout. And then based on that, you can make management decisions that are informed by all the different categories, at this watershed scale. And it includes a whole range of factors, which I won't go into in too much detail, but related to climate, related to ecosystem conditions, etc. All the information from the CSI is available on TU's website, and I'm pretty sure that the Forest Service has already been in touch with us about the databases that support the CSI, and we've already given them to you guys as part of this process. And then last, I wanted to just highlight, so just recently over the last 2 years, we've been working in partnership with BLM to basically take the CSI framework and expand it beyond fish to all aquatic organisms. And there's sort of 3 components of this. One is a freshwater assessment for aquatic species, so all native aquatic vertebrates, endemic aquatic invertebrates of plants, rare and native aquatic invertebrates and plants, and then all exotic aquatic species. A freshwater assessment, which is basically about the habitat conditions using our CSI framework, and then the scoring system applied in the CSI. And so this just gives you a sense of all the different categories of information and the number of species that we collected. So really similar to the one that was just shown earlier that you guys put together, but just a little bit more expansive. And then in the case of its application to the BLM, we also highlight sensitive species in their management areas so that you can just narrow down to, oh, these are our target species. And so very similar to what we saw before, spatial data collection, range, critical habitat, like this example is for red-legged frog, historical observations, current observations. So we collected those for a huge number of species using a lot of records. This is just to give you a sense of what all went into it. And this is the sort of product at the California scale, patterns of native diversity, ESA listed species richness. In this case, as an example, the BLM sensitive species richness, and so on and so forth. But then all of this is actually, that California map is extrapolated from things that are quantified at the HUC 12 scale, so we can also zoom in on like the management area for a particular office. And then, like I said, there's all the sort of physical habitat parameters that are in there too, and then things related to climate, etc. And then there's a lot of geospatial data out there in the world right now. And one of the challenges with that data, I think, is how do you make it usable at the project scale? How do you make it usable in the NEPA process? How do you tie it back to be able to actually do prioritization on the ground? So we took the approach that we designed for Mountain Meadows, that's kind of like this limiting factors analysis for a particular critter, and then looking at what the actual project effects are. And we designed a version to go with the CSI aquatics thing. So it takes a bunch of different limiting factors categories that you essentially score a project that you're designing in, and then you score the design, and then by multiplying the project score by the limiting factors, you create a weighted score for the project. And I share this just to provide a conceptual approach for what we think makes sense in terms of doing management in a way that's effective, that's systematic, that takes the landscape scale approach and the project scale approach and integrates them, and that has the sensitive species in mind, but that is scoring projects in a way that's not just beholden to the sensitive species. So the information on the species and its limiting factors is decoupled from what the project's effects are. So you can switch species or talk about multiple species, and everything's not either seen through the lens of that target species that you're managing for or not seen at all. And then you can also scale this back up to the landscape scale. So if, for example, you have a project where you are decommissioning roads and a big part of your landscape scale lousy CSI scores because you have a huge number of road impacts, you can have a metric that is, and that's also a factor that's really impacting your target species. You can have a metric that is, miles of road per mile of riparian area. And you can quantify the effects at the project scale, and then over time, you can take those project effect scores and you can watch the color on your map change by virtue of the work that you're doing, or not change, and figure out if you are, spending your dollars wisely, and also just kind of make decisions about, there are some things that you're not going to ever be able to really see the effect of. And that doesn't necessarily mean that those things aren't important, but when you're thinking about management at a landscape scale, you want to be able to draw lines between those things which you'll be able to track the big effects of, see change from, and those things which you know are doing some good, but you're not going to be able to actually track that change, and be transparent about the way that you prioritize those and value them. And that's it. I think one last thing I want to just highlight is going forward, like I said, we put a lot of emphasis on restoration, but I think like the line between restoration and just effective management of landscape is becoming increasingly blurred, and what we call restoration versus what we call enhancement. So I really just want to advocate for using these sorts of approaches and in monitoring, so making monitoring active and making those data sets used in monitoring active so that our management practices are like research driven and driving our adaptive management approaches and bouncing back and forth between the landscape scale and the project scale in that sort of way, kind of fusing those management roles. Thanks.
So we're running just a few minutes late, and with your permission, Joanne is our last speaker, and then we're going to take a break.
Yeah. Okay, I'm going to give you something different to look at, but Aaron left the room when I needed technical help, but Phil's going to try to help me. So for those of you that don't know me, I am an ecologist of 20 plus years, mostly with the Forest Service. And I've worked on all kinds of things, old growth forests, vegetation mapping, riparian systems. So really what I'm providing is the context for the water and the aquatic ecosystem. But I'm going to show you 2 fire videos, because for the last 10 years before I left to teach and come back, I would set up sensors and measure vegetation in detail ahead of wildfires. And is fire good or bad? Well, it's all different things. And the first video that I'm going to try to show you, if we can get it going, or I'll show you later, is from the Black Mountain 2 fire in Montana in 2003, just outside of Missoula, Montana. And this is one end of the spectrum. And it should just be the video.
No, it's EED, wasn't it?
No, it's video. If it doesn't work. I was also going to talk about the ecology of riparian areas and how fire suppression has resulted, especially in the forested systems, in a lot of conifer encroachment, and how that's affected the deciduous litter inputs into the aquatic ecosystem and the riparian ecosystem and the amount of shading. I really want to show you this, though, if it works, but it's not easy to do. One of the places that Renee talked about was the Kern Plateau, and that's one of the areas that I've spent a lot of time measuring fire behavior and effects for Brent Skaggs, from the Fire Management Officer from the Sequoia National Forest, and he'll be here tomorrow. And there we see a lot of varied fire behavior. On the Kern Plateau, they use managed fire, or in the past we called that wildland fire use fire, where if there's a natural ignition, they let the fire spread for days, and it can be in all kinds of conditions. And of course, you know, it's hard to predict, are the weather conditions going to get to the point where it's going to really go on you and have effects you don't want. And that's really what Phil Bowden was talking about. He was talking about trying to really understand better and hone down our ability, I might have to give this up, to understand when to apply the fire. But I asked Brent Skaggs, I said, you know, what happened when you burned in the golden trout habitat?
On this side
Here it is.
now,
12 feet.
Perfect.
yeah, the RA just dropped 3% in the last half hour and 11% in the last hour. And the white button.
So what do you think the winds were that day? 3 miles per hour. That's all wind from the fire. All right, the reason why I'm showing you that one is that was in a chimney, a little drainage. And that was a dry year. And I just show that I'm actually an advocate for active management, including fire, all kinds of tools, mechanical. But I show that because until I saw it myself, I didn't really believe it. And it doesn't always occur, but it just gave me a great respect for the fact that I think it's good to think of light management in riparian areas and old forests. But we have to understand there may not be as many chances anymore. So you really have to weigh those two things. The other fire I was going to show, but I'm not going to try, is a much gentler one that occurred in similar dry conditions on the Tahoe National Forest. But in that case, it had been prescribed burn before, and it was had been thinned. You don't always have to do both. And everyone else had left the site. We were safe, though. We were always safe. I had the very best fire people with me, and we were in a safety zone. But we set up the cameras and the heat triggers, and it was just this, you know, nice little benign fire. So the dry conditions, it depends on the context, where you are. So at that, let's take a break, and then we can come back and have the panel discussion, question and answer, and discussion with the audience.